Hello scholars, welcome, Mr. Hinkle here. Today's lecture we're going to discuss the processes that break down bedrock into smaller chunks called sediments. Yes, we're talking about weathering. So, objective, describe the various processes of both physical and chemical weathering. We'll define them first. So, bedrock is the solid rock that makes up Earth's outer crust. And there are three types of rock in the rock cycle. Igneous, rocks that solidify from molten material. Sedimentary, rocks that have been deposited and lithified into sedimentary rock. And metamorphic, rocks that have changed their form. In this lecture, we're talking, or in this general topic, we're discussing sedimentary rocks. And in this lecture particular, we're discussing how do we generate sediments. So, how do we? Through the process of weathering, turning bedrock, rock that makes up Earth's outer crust, into small particles called sediment. And this can happen in two ways, physical and chemical. We'll talk about physical weathering first, also known as mechanical weathering. So this is the actual breaking up of rocks into smaller pieces. Okay, let's do a little bit of a road map here on the board. So we've got weathering. Right now we were going to talk about physical. We also mention chemical, which we will come back to later. This is a big rock. It's split in two. How the heck did that happen? Oh, I know. By the processes of physical weathering, and of which there are many. Let's start to talk about these. So, how this happens is through various agents. Wind, water, ice, really important. Pressures, temperatures, salts, biological activity, like this tree that's literally growing into the rocks. One of my favorite things on Earth when I'm hiking up in the mountains, high alpine environments, it's rocky and the conditions are rough, and then all of a sudden you see a tree clinging to the bedrock whose roots are grown right into a crack inside that rock. It's like, what the heck? How did that tree do that? Well, it pried its way in there and it's carving out a little niche for itself. So, first type of physical weathering, jointing. A joint is a break in bedrock without displacement. And this happens as rocks that are buried underneath the surface of the earth start to uplift in the overlying material. The overburden is relieved or removed, and that takes pressure off of those rocks. Well, that change in pressure causes a slight shift in the rocks, a very slight shift in their size, and that shift causes them to break. Well, that breaking or jointing can create opportunities for weathering to occur. So this is a type of weathering that happens during the process of exhumation. You have a decrease in temperature and pressure as the rock is being lifted up towards the surface. We see a special kind of jointing in large domes of igneous bedrock. Here is Half Dome. You can see the cables here. Have you ever climbed it? I've been up to the top of Half Dome 3 times. It's a really cool thing, pretty scary, and you're immersed. I mean, everywhere we go, you are immersed in geology, but when you are climbing Half Dome, you are immersed in geology, literally climbing up one of the sides of an exfoliation joint. Here you can see this is an exfoliation joint. It's kind of like the layers of an onion that peel concentrically out from the middle. And same thing, when you have expansion and pressure release, that pressure release will cause breaks in the rock known as joints. Let's keep going. frost wedging. So this one is like if you've ever put a soda in the refrigerator or in the freezer, you're like, man, this soda is not cold enough, or i.e. fill in your favorite beverage, and you put it in the freezer and then all of a sudden, pow, it explodes. Well, the soda explodes because the carbonation is released, but the water content that's inside of it breaks the vessel, the can which it's in, because water expands when it freezes. So if there is a joint in a rock or a crack in rocks on the surface, water gets in there and it freezes. That frozen water is going to expand and break the rock. We see this in cold climates especially because we need ice to be created for frost wedging to occur. Salt wedging. Similar to frost wedging, but instead of ice expanding, it's salt. There's dissolved salts in the ocean. Have you ever been swimming in the ocean and you're swimming around and this big wave smashes you in the face and water goes up your nose and you start choking? You're like, oh my gosh, it's so salty. Well, it's because the oceans have an average salinity or dissolved salt content of about 3.5%. So when ocean spray gets on rocks, these salts can accumulate, and when the salt accumulates, it also expands, and that expansion of salts creates unique sedimentary features, or weathering features would probably be a more accurate term, through the growth and wedging of the salt crystals. Roots do something very similar. So our next type of physical weathering is root wedging. I talked about this a little bit when introducing the concept, but roots can work their way into cracks, they can work their way through soil, they can go into bedrock, and then as the tree grows, the roots expand and actually break apart the rock. When roots are preserved in rocks as fossils, we call it rhizolith. This isn't a rock, this is asphalt, but it's the same kind of thing. We can see the roots from the tree growing into the sedimentary bed, or the layer of asphalt, breaking it apart, and the outlines and traces of that movement of the roots. Thermal expansion. So this happens when there's a forest fire or a heat source on the overlying rock. The heat source could even be, as our image shows here, the sun heating up rocks during the day and then those rocks cooling off at night. And the repetition of the heating and the cooling causes expansion and contraction, which can break down the rocks into smaller pieces. The definition of physical weathering, causing smaller pieces or sediments to form. So thermal expansion would be our 1, 2, 3, 4, 5th type. Cute. Cute. Maybe not so cute. Destructive. Animal attacks. So burrowing gophers, worms, different types of animals that live in the subsurface can burrow into rocks, can break them down. Weathering is the process of, physical weathering is the process of actually breaking down rocks into smaller pieces. Humans are really good at it. We have big old machines where we break and remove the overlying rocks. This is a rock quarry. Very necessary for human civilization, but also humans apply geologic forces, which is really awesome and kind of scary at the same time. Animal attack. So animals are an agent or are a type of physical weathering, including us, myself, and you included. Okay, physical weathering is the breakdown of rocks into smaller pieces. Chemical weathering is the decomposition of rocks due to chemical reactions. This happens when rocks come into contact with either water or air, both agents of chemical weathering. Dissolution. Dissolution is basically when water interacts with minerals and it dissolves those minerals into solution. It basically separates the elements that have chemically bonded to form the mineral into their own ions and then can transport those ions in solution. Let's see. Dissolution is chemical weathering. Number one, water dissolving minerals. Dissolution can lead to entire types of geologic features. This is a really cool image of karst topography, or topography that has been created through the dissolution of rocks and minerals. Here you see, this is layers of limestone, all these different caves. It goes very extensively back in there. Characterized by sinkholes and caves. Pretty cool. Okay, hydrolysis. So hydrolysis is going to be when water reacts with minerals to form other minerals. So chemical reactions that are occurring in water, where the water mixes with minerals and it breaks down those minerals, it transforms them into other minerals. Often we get carbonic acid forming when carbon dioxide involves in the water. The carbonic acid can lead to a series of chemical reactions because more acidic conditions in the water have higher weathering potential. This is the source of chemical sedimentary rocks. Essentially, we're changing the minerals from rocks, we're dissolving them, we're changing them into other types of minerals, we're transporting them, and then we are depositing to form chemical sedimentary rocks. One of our 4 types of sedimentary rocks, we have clastic, chemical, biochemical, and organic. Let's keep going. Oxidation. So hopefully there are no lonely bikes in any of your backyard, side yard, garage. Hopefully you are riding your bicycle every day and just loving your life every time you get on it. But the rusty bike, it does exist, and I know it. Steel is not a mineral because a mineral must be naturally occurring from geologic processes, inorganic, solid with a definite chemical composition and a fixed crystalline structure. Steel is man-made, but the iron in the steel undergoes reactions with oxygen through the process of oxidation, which creates iron oxides or rust. Same thing can happen to minerals. Minerals exposed in the rocks on Earth's surface can interact with the sun, iron specifically, and it can oxidize, forming rust and chemically altering the original rock or material. In this case, it's a bike, but the bike is just kind of tuning us into what happens for Earth materials. Hydration, last but not least. We've got the absorption of water into the structure of minerals. We see this in sediments like mud cracks that absorb water, and then that can expand and weaken the rock, especially when it dries out. So hydration can chemically alter rocks to break them down into smaller pieces. Great, so we've got physical weathering, we've got chemical weathering, and we discussed one, and then we discussed the other. But in the real world, on our Earth, these two work hand in hand together. Physical weathering promotes chemical weathering, and chemical weathering promotes physical weathering in this beautiful balance and harmony. As you break rocks down into smaller pieces, there is more exposed surface for chemical weathering to occur. This is a surface area to volume ratio. This cube has 1, 2, 3, 4, 5, 6 sides. Break it up, and it's got many more sides. Break it up, many more sides. Break it up even more, way more sides. So what we're looking at is physical weathering increases the surface area to volume ratio for chemical weathering. Chemical weathering breaks down the structure and the integrity of a rock, which allows for greater physical weathering to occur. And when you put these two together, you get a unique process called spheroidal weathering. Because corners, let's see if I can do it. Corners are going to have two sides weathering on them. There's one, there's two. I'm sorry, this is an edge. Let me restate that. Edges have two sides of weathering occurring on them. A corner actually has 1, 2, 3. Because of the various faces on a block of rock experiencing erosion or weathering, and edges having two faces weathering, goodness gracious, edges having two faces weathering them, and then corners having three faces weathering them, what we end up with is features where rocks are very rounded. How did we get round rocks? What the heck? Those are awesome. Well, that's a product of both physical and chemical weathering acting in harmony for a special case of weathering called spheroidal weathering. Super cool, really awesome. If you see round rocks, you can say, hey, spheroidal weathering. We also have differential weathering where different minerals weather at different rates. And the two big examples are in the photo above. That's a hoodoo, where you have various rock layers eroding at various rates. You can see the more resistant layer above is on a pillar by the less resistant layer below. This is the beach. Beaches are made of primarily the mineral quartz. They've been weathered, eroded, transported, deposited, and they locate here. All the other minerals have dissolved and been dissolved into solution and are somewhere else remaining here. So differential weathering is the reason why our beaches commonly are made of sand-sized grains of the mineral quartz. Okay, wow, whew, we did it, you did it, congratulations. We are talking about weathering. Weathering is the physical and chemical breakdown of rocks. Physical is actually mechanically breaking rocks apart. Chemical is the dissolution of rocks using chemical reactions. And there's a lot of different ways these happen, but they don't happen in isolation. They happen together to give us unique features that help us to understand some of the landforms and some of the landscapes that we see on the surface of our Earth today. So this is our discussion on weathering. Thank you so much.